Hello everyone, how are you all? Hope all you are fine. In this video we will see data types and their representation, metadata and data value chains. Now let's come to the first topic, data types and their representation. What is data type? Data types can be described from diverse perspectives. In computer science and computer programming, for instance, a data type is simply an attribute of data that tells the compiler or interpreter how the programmer intends to use the data. Data types can be seen as respective of computer programming perspective and respective of data analytics perspective. When we come to data types from computer programming perspective, almost all programming languages explicitly include the notion of data type, though different languages may use different terminology. Common data types include integers. Int is used to store whole numbers, mathematically known as integers. Booleans, bool, is used to represent restricted to one of two values, true or false. Characters, char, is used to store a single character. Floating point numbers, float, is used to store real numbers. Alphanumeric strings, string, used to store a combination of characters and numbers. Now let's come to data types from data analytics perspective. From a data analytics point of view, it is important to understand that there are three common types of data types or structures: structured, semi-structured, and unstructured data types. 1. Structured data. Structured data is data that adheres to a predefined data model and is therefore straightforward to analyze. Structured data conforms to a tabular format with a relationship between the different rows and columns. Common examples of structured data are Excel files or SQL databases. Each of these has structured rows and columns that can be sorted. 2. Semi-structured data. Semi-structured data is a form of structured data that does not conform with the formal structure of data models associated with relational databases or other forms of data tables, but nonetheless contains tags or other markers to separate semantic elements and enforce hierarchies of records and fields within the data. Therefore, it is also known as a self-describing structure. Examples of semi-structured data include JSON and XML are forms of semi-structured data. 3. Unstructured data. Unstructured data is information that either does not have a predefined data model or is not organized in a predefined manner. Unstructured information is typically text-heavy but may contain data such as dates, numbers, and facts as well. This results in irregularities and ambiguities that make it difficult to understand using traditional programs as compared to data stored in structured databases. Common examples of unstructured data include audio, video files, or NoSQL databases. The next topic is metadata. What is metadata? Metadata is data about data. It is not a separate data structure, but it is one of the most important elements for big data analysis and big data solutions. Metadata is data about data. It provides additional information about a specific set of data. In a set of photographs, for example, metadata could describe when and where the photos were taken. The last topic for today's lesson is data value chain. What is data value chain? The data value chain is introduced to describe the information flow within a big data system as a series of steps needed to generate value and useful insights from data. The big data value chain identifies 5 basic steps. These steps are data acquisition, data analysis, data curation, data storage, and data usage. What is data acquisition? It is the process of gathering, filtering, and cleaning data before it is put in a data warehouse or any other storage solution on which data analysis can be carried out. Data acquisition is one of the major big data challenges in terms of infrastructure requirements. The infrastructure required to support the acquisition of big data must deliver low, predictable latency in both capturing data and in executing queries, be able to handle very high transaction volumes, often in a distributed environment, and support flexible and dynamic data structures. 2. Data analysis. It is concerned with making the raw data acquired amenable to use in decision-making as well as domain-specific usage. Data analysis involves exploring, transforming, and modeling data with the goal of highlighting relevant data, synthesizing and extracting useful hidden information with high potential from a business point of view. Related areas include data mining, business intelligence, and machine learning. 3. Data curation. It is the active management of data over its life cycle to ensure it meets the necessary data quality requirements for its effective usage. Data curation processes can be categorized into different Activities such as content creation, selection, classification, transformation, validation, and preservation. Data curation is performed by expert curators that are responsible for improving the accessibility and quality of data. Data curators, also known as scientific curators or data annotators, hold the responsibility of ensuring that data are trustworthy, discoverable, accessible, reusable, and fit their purpose. A key trend for the duration of big data utilizes community and crowdsourcing approaches for data storage. It is the persistence and management of data in a scalable way that satisfies the needs of applications that require fast access to the data. Relational database management systems have been the main and almost unique solution to the storage paradigm for nearly 40 years. However, the acid atomicity, consistency, isolation, and durability properties that guarantee database transactions lack flexibility with regard to schema changes and the performance and fault tolerance when data volumes and complexity grow, making them unsuitable for big data scenarios. NoSQL technologies have been designed with the scalability goal in mind and present a wide range of solutions based on alternative data models. 5. Data usage. It covers the data-driven business activities that need access to data, its analysis, and the tools needed to integrate the data analysis within the business activity. Data usage in business decision-making can enhance competitiveness through the reduction of costs, increased added value, or any other parameter that can be measured against existing performance criteria. This is all about today's lesson. In today's lesson, we have seen that data types, metadata, and data value chain. In the next lesson, we will see the concept of big data. Thank you for watching. See you in the next lesson. Don't forget to subscribe this channel to get more videos.